Welcome to the Space Tech channel. Never miss latest space happenings by subscribing to this channel. Now that the James Webb Space Telescope, JWST, is safely in space and nearly fully deployed, it's worth taking a look at some of the cosmic mysteries astronomers hope to unlock with NASA's new flagship observatory. Among a list of high-priority targets, it will interrogate two of the most enigmatic puzzles facing astronomy and cosmology today. JWST is optimized to look far out into the cosmos and deep into the past to image the very first stars and galaxies. It will also help better characterize exoplanets and search for evidence of life in the atmosphere of worlds around other stars. And it may well provide insights into some of the most esoteric questions in cosmology, helping to better characterize, to characterize at all, the nature of dark matter and dark energy. And while digging deep into these mysterious entities that together which behave as if they are more massive than the visible matter and energy in them would dictate, until effects of dark matter's added mass would cause the universe's expansion to slow down. Both dark matter and dark energy are dark because they don't appear to interact with light or normal matter, but they also appear to outnumber all that stuff we can see out there. Scientists estimate 25% of the universe consists of dark matter, and some 75% of dark energy, leaving just 5% for everything else we see. How will JWST see dark matter and energy? JWST is the most powerful space telescope ever launched, with a 6.5-meter diameter primary mirror and the ability to focus on single objects very, very far away. When it comes to dark matter, this should allow JWST to make use of gravitational lensing, the way the mass of a galaxy bends light from galaxies behind it as the photons pass by the foreground galaxy. By imaging distant galaxies behind closer galaxies, JWST will enable scientists to measure the total mass of the closer galaxies by how much they bend the light from the background galaxies. The difference in the predicted mass of those foreground galaxies and what JWST measures could be the mass of the hidden dark matter around the galaxy. WEBB will be particularly well suited for this type of measurement, because its very sharp images will allow very small disturbances to be measured, reads a NASA FAQ on JWST and dark matter. And, because it can see so deep into space, giving it access to many more background galaxies to measure disturbances caused by this gravitational lensing effect. Dark energy was first revealed based on the observations of distant supernovae and confirmed in 2003 with measurements of the cosmic microwave background, the afterglow of the Big Bang. Supernovae are like lamp posts, Space Telescope Science Institute astronomer Adam Rees tells in verse. They allow us to make measurements of the expansion rate of the universe. Rees was one of the scientists who shared the 2011 Nobel Prize in Physics for the discovery of dark energy, and he says it's exactly the qualities you want for imaging the first stars in the universe and studying the atmosphere of distant worlds, but it's not the best tool for studying dark matter and dark energy. Telescopes that are optimized to study dark energy try to observe a large fraction of the sky, Rees says. The way we learn about it and measure it is by adding up its consequences over a lot of space or a lot of volume. The upcoming Nancy Grace Roman telescope, expected to launch in 2027, will by contrast sport a wide field of view capable of imaging wide swaths of sky, which is exactly what you need to measure the effects of mysterious forces on large structures or portions of the universe. It's sort of like saying, can I measure gravity using a grain of sand? Yeah, but you'd be better off using a cannonball, Rees says. JWST and Nancy Grace Roman could, however, work together once Roman is deployed. Roman may identify hundreds of distant supernovae, for instance, but JWST will be the one to make the most precise measurements of those distant lampposts possible. JWST might follow up a small number of them and look at them in more detail, Rees says, basically stress test them and see if they're telling us the truth. Hope you liked this video about JWST unearthing the dark matter. Please like and subscribe for more such content.